So Mendeleev arranged the element in the increasing order of their atomic mass. Okay. Hello everyone, I am Lokendra. I am chemistry faculty at Toppers Academy. Today we are going to deal with the topic periodic table, right? For our convenience, I am going to divide this chapter into 4 parts. Okay. So these are, first part is, in the first part we will deal with periodic laws on which our periodic table is based. Okay. Second part will be nomenclature of atoms which having atomic number more than 100. Okay. And third part you will see that classification of elements based on electronic configuration, right? And the last part will be for this periodic properties, right? Periodic properties. Okay, so we are going to start with the topic periodic laws. Okay, actually Dove Reiner started to get an idea on which we can arrange the element. Okay, so he gave the law of triads. After him Newland gave the law of octaves. But the important 2 laws are, one is Mendeleev's law, and the another is Henry Moseley law, right? So Mendeleev arranged the element in the increasing order of their atomic mass. Okay, so he arranged the element in the increasing order of their atomic mass. He said if we arrange elements in their increasing order of atomic mass, so after a certain period we will get such type of element which will have similar or same type of similar properties. Okay, chemical or physical properties. And Moseley said that if we set elements in the increasing order of their atomic number, so after a certain period we get elements of similar properties. So according to Moseley, we arrange the elements in atomic number. According to Mendeleev's law, we arrange the elements in atomic mass. This law, Moseley's law or modern periodic law, it is also known as modern periodic law, our modern periodic table is based. Okay. So see, we arrange the elements in the increasing order of atomic number in the modern periodic table. Okay. Now we are going to start with the another topic, nomenclature of elements having atomic number more than 100. So IUPAC gave this funda because of which we can write the name of elements which have atomic number more than 100, but these names are temporary names. After these temporary names, IUPAC will decide the permanent name for that particular element, right? So IUPAC, International Union of Pure and Applied Chemistry, right? So 0 for nil, 1 for un, 2 bi, 3 tri, 4 quad, 5 pent, 6 hex, 7 sept, 8 oct, 9 n, right? So see, suppose there is an element having atomic number 105. So 1 for un, right? 1 for un. So 1 for un, so un. 0 for nil, so nil. 5 pent, right? Pent, and at the end we add IUM, right? It is the name of element. What will be the abbreviation? Abbreviation will be the short form, right? Abbreviation, that means short form. U, un, U from un, N from nil, P for pent. It will be the abbreviation, and first letter in the abbreviation will be capital and remaining letter will be small. Okay. And one more thing, suppose if element having I at the end, so we will remove one I. For example, suppose I am going to write name for this element, atomic number 113. So for this we will write the name. 1 represents un, one, un. Okay, so try, and at the end we will add ium, so ium. But what happening here, 2 I are there, right? 2 I are there. So in such type of condition we will remove one I. Okay, so I will remove one I, so I will write just um. I will write just um, not ium. One I has been removed. Barabar? Okay. That is, and this is all about the nomenclature of atoms having, of elements having atomic number more than 100. Okay, so I hope you understood all these topics, the two topics, periodic laws and nomenclature of atoms having atomic number more than 100. Okay, this is was. Now we are going to deal with this third topic, classification of elements based on electronic configuration. Classification of elements based on electronic configuration. So electronic configuration, first of all we will write the electronic configuration for a particular element, and we will see that in which subcell the last electron is going to enter, and on the basis of this subcell we will arrange this element into the periodic table in the particular block. So for example, suppose there is an element having atomic number 11. So first of all we will write electronic configuration for this, right? It will be 1s2, 2s2, 2p6, 1s2, 2s2, 2p6, 3s1. So last electron enters in S subcell, so obviously it will belong to S block. Okay, suppose I want to write for 17, so it will be 3s2, 3p5. So last electron enters to P subcell, so obviously I will arrange this particular element in P block. So there are 4 blocks in our periodic table as PDF. So this is based on their electronic configuration, right? So in this way we are having 4 blocks: S block, P block, D block and F block, right? So what we are going to do, we are going to just see 2 to 3 points regarding these block elements, right? S block elements, see how many electrons can we fit in S block and S subcell. 2 electron can be fit in S subcell, because in S subcell there is only 1 orbital, so 2 electron can be fit in 1 orbital. So obviously 2 electron can be fit in a S subcell. So that's why there are 2 groups in S subcell. In S block there are only 2 groups, 1, 2, right? It is hydrogen here. This is S block, right? Here 10 groups will be there, group. Here 6 groups will be there. Why? This is P, this is D, this is S block and this is F block here, right? 2 line at the bottom of our periodic table, right? So why these are only 2 groups in S block? Because only maximum 2 electrons can be fit in S subcell. Why here 6 groups are in P block? Because P subcell can have 3 maximum orbitals, and in 3 maximum orbitals 6 electrons can be fit. Okay, so that's why P1, P2, P3, P4, P5 and P6. That's why 6 groups are in P block. That's why 2 S1 and S2. That's why 2 groups in S block. D1 to D10. D1, D2, D3, D4, D5, D6, D7, D8, D8, D9, D10. That's why 10 groups are in D block. Okay. So points related to S block element. There are only two groups in S block, first and second, and first group element are known as alkali metals. Second group elements are known as alkaline earth metals. Barabar. And these all are reactive metals with low ionization potential. Low ionization potential, that means we can easily remove an electron from their valence shell. Okay. So first group element release one electron from valence shell and will be converted to in +1 charged ion, right? Like Na will be converted to Na1 positive. Second group element will have 2 positive charge. So like magnesium will be converted to magnesium 2 plus very easily, right? So the oxidation state of first group element is +1 and oxidation state of second group element is +2. It is always fixed. It cannot be changed, right? In a compound, in every compound, right, of first group element, you will see that oxidation state of first group element and second group element will be +1 for first group, +2 for second group element, right? For P block element, this contain metals, non-metals and metalloids. What are metalloids? Metalloids are the element which show the property of both metals and non-metals, right? In P block, metallic character increases from top to bottom, right? While non-metallic character increases, it was about a group, increases from left to right, obviously in a period. It is about period. Non-metallic character increases from left to right in a period, while metallic character increases from top to bottom in P block elements. We are talking about 6 groups which are present in P block, right? Now about D block elements. D block elements, they show variable valencies or oxidation states. That means they can have more than one valencies or oxidation states, right? They form colored ions, right? Another thing, they can act as catalyst. They show paramagnetism, right? Got it? So this was all about D block elements. And about F block elements, the 2 rows at the bottom part of our periodic table are known as F block elements. These also are known as inner transition elements, right? D block elements are known as transition element, while S and P block collectively are known as main group element or representative elements. I mean to say, if I take the collection of all S block elements and P block elements, then this collection of all the elements of S and P block will be known as main group elements or representative elements. Barabar? While D block elements is known as transition elements, and D F block elements is known as inner transition element. Got it? Transition elements. Barabar. Now some points regarding F block elements. So atomic number 58 to 71, these are 14 elements known as lanthanoids. Atomic number 90 to 103, actinoids. And actinoids are most of the actinoids are man-made, that means they are synthesized in the chemical laboratory, and actinoids are radioactive also. Radioactive, what is the meaning of radioactivity? They release alpha and beta particles, okay, they are not stable, right? Actinoids, right, are radioactive, and elements after uranium, that means atomic number 92, are known as transuranium elements, okay, got it? So this was all about the third part. We have discussed classification of element based on their electronic configuration, right? And now we are going to deal with the last part of this chapter, periodic properties, right? So I have discussed here, if the last electrons enters in S subcell, so obviously it will present in S block. If last electron enters into P subcell, so it will be present in P block. If similarly D and F, right? So there are 10, this is 1 to 2 groups, there are 18 groups total. So D block elements contain 3rd to 12 groups, there will be total 10, 3 to 12, right? 3, 4, 5, 10, right? 3 to 12. So these are 13 to 18 groups, they are total 6 in number. 6 groups are in P block element, right? Barabar. And all F block elements are considered in 3rd group, here and here. All F block elements are considered as in all F block elements are considered in 3rd group of periodic table. There are total 7 period from left to right. Period, that means from left to right. Group, that means from top to bottom. There are 18 groups in our periodic table and 7 periods in our periodic table. Period, that means from left to right. Group, that means from top to bottom, right? So periodic properties, this is the last topic of our chapter, right? So see, periodic property, right? So what are the periodic properties in this chapter? Atomic radius. First is atomic radius. What is atomic radius? The radius of atom, right? Obviously if radius of atom will increase, so size of atom will increase. So I can say I am dealing with atomic size or atomic radius, both are same thing, because atomic size is represented by atomic radius. So if atomic radius is high, so obviously atomic size is also high. So if someone talks about atomic radius or atomic size, both things are same considered, right? So what is the meaning of atomic size? Suppose this is our atom and it is the nucleus of that atom. It is the nucleus of that atom in which neutron and proton are fixed, right? And around this atom there are circular orbits in which electrons are revolving. So what is the radius? The distance from the center of the nucleus to the outermost electron is known as radius of that particular particular atom. It is the radius. Suppose it is having two circular orbits, then in this case, for calculating the radius, I will measure distance from center of the nucleus to the outermost cell, this to this. Now this will not be the radius, this will be the radius from center of the nucleus to the outermost cell. If there are two cells, so obviously from center of the nucleus to the second cell. If there are 4 cells, so obviously from center of the nucleus to the 4th cell, it will be the radius, obviously, right? So in this case, the radius will be this length. In this case, the radius will be this length, right? So I can say that radius is distance from center of nucleus to the outermost shell or outermost electron cloud. It is the atomic radius, right? Now let's talk about atomic radius. Atomic radius. As you have seen that as number of cells increases, so obviously the distance from the center of the distance from center of the nucleus to the outermost cell will increase, and as we will increase the number of shells, so obviously the atomic radius will increase, because the distance from the center of the nucleus and shell will increase. Okay, so obviously if there will be higher number of cells, there will be higher size. Okay, atomic radius. So atomic size is proportional to number of cell. And one more thing, if it is inversely proportional to Z effective. Z effective, what is Z effective? The attraction force, nuclear attraction force experienced by the electron revolving in the outermost shell of an atom, right? So experimentally it is observed that atomic size proportional to n square upon Z effective. Why it is n square? It is experimental observation, I cannot explain, right? Atomic size proportional to n square upon Z effective. I can explain that why n is in numerator, why proportional to n, and why Z effective is in denominator. I am going to explain that term, right? So see, if in a period, so if in a group from Li, Na, K, R, B, right? So it is 2s1, it is 3s1. If you will write the electronic coefficient, you will get 2s1 for 3Li, 3s1 for Na, and 4s1 for this. So you can see that here 2 cells are there, here 3 cells are there, here 4 cells are there. So obviously the distance from the nucleus is increased, so the radius is also increased now. So in a group, as we move from top to bottom, number of cell increases, so atomic size increases. In a group from top to bottom, obviously if I am talking about a group, so obviously I am talking from top to bottom. Atomic size increases. Got it? Atomic size will increase. Suppose if we talk about in a period, so Li, Be, BCNOF, 2s1, 2s2, 2p1, 2p2, 2p3, 2p4, 2p5, second cell only 2, 2, 2, 2. That means there are only 2 cells, right? But the number of protons in nucleus will be 3 for this, 4, 5, 6, 7, 8, 9 for this. So you can imagine that I will represent nucleus in which 3 protons are there. That means 1 proton having +1 charge, so 3 proton will have 3 plus charge electron, while here 9 proton, because its proton will have 9 protons, so 9 positive charge, 9 atomic number na, so electron is revolving here. So now you can imagine that here 3 protons are attracting this electron, while here 9 protons are attracting this electron. So obviously the attraction of 9 proton will be very effective as compared to the attraction due to 3 proton. So obviously its size will be decreased. That means electron will revolve here, it will be attracted towards nucleus, so its size will be decreased. So I can say that if I move from left to right, the size decreases. If I move from left to right in a period, size decreases because Z effective increases. That means nuclear attraction force increases, or I can say the number of protons in nucleus increases. Okay. In a group, in a period from left to right, obviously size decreases. Got it? Barabar. Now ionization potential. Ionization potential and electron gain enthalpy. And one more thing, electronegativity. Got it? So let me write the definition first. Minimum amount of energy required to remove most loosely electron from the valence shell, right? It is the amount of energy, right? Electron gain enthalpy, amount of energy released when electron is added to the valence shell, right? Electronegativity, tendency to attract the shared electron pair. Now we'll understand it. See, suppose this is the this is proton, this is nucleus in which protons are there, so protons having plus charge, obviously, right? So that's I have mentioned positive charge. So this is the orbit in which electrons are revolving. So the minimum amount of energy that is required to remove this electron will be known as ionization potential. So obviously is the electron in first shell and it is having also second shell also. So obviously now I will remove this electron, and the amount of energy required to remove this particular electron will be known as ionization potential. In this case I am not going to remove this electron because I will have to remove most loosely electron. This electron will not be most loosely bounded. This electron will be loosely bounded because the distance is higher. The nucleus will attract this electron more effectively. The amount of energy released, that means suppose fluorine, so 2,7, so only 2 electron in second shell and 7 electron, 1 2 3 4 5 6 7. So obviously it want to complete its octet. So if it will accept the electron in its valence shell, so it will be stabilized, and when it will be stabilized it will release the energy. The amount of released energy will be known as electron gain enthalpy. Electronegativity, so suppose HF, it is a bond between H and F, and one bond is formed by 2 electrons. So 2 electrons are shared, one from hydrogen and one from fluorine. So this bond, this electron pair should be present in between of H and F. But here now see the electronegativity value. The atom which is having higher value of electronegativity will attract the shared pair of electron towards itself. So fluorine have high value of electronegativity, so it will attract the electron towards itself. So now the electron pair will not be present at the mid, it will be present slightly towards fluorine atom, right? So because it is having higher electronegativity. Now see, we have seen the trend of atomic size, atomic radius. In a group, size increases. In a group, size increases. So these all are opposite to atomic size. So in a group, if atomic size increases, it will decrease, it will also decrease, it will also decrease, right? We have seen that atomic radius in a period decreases, in a period decreases, so opposite of decreases increases. So in a period, they all will increase, increases and increases. Got it? And one more thing, if I talk about ionization potential and electron gain enthalpy. Electron gain enthalpy now, ionization potential. So actually ionization potential is directly proportional to stable electronic configuration. That means stable electronic configuration, P3, P6, D3, D6 or D10, half filled and fully filled, P3, P6, D5, D10, F7, F14, these are stable electronic configuration, and in such cases the atom will be stable, and it will not be very easy to remove an electron from a stable electronic configuration, because no atom want to be unstabilized, right? So in a period, as we know that ionization potential increases, So if I talk about second period, C and O, so the order should be like this. But if I write the electronic configuration, it is 2p2, it is 2p3, it is 2p4. So it is having half filled stable electronic configuration. So the ionization potential for this case will be high, the order will be changed, and correct order will be this. Nitrogen will have higher ionization potential as compared to oxygen, because it is having stable electronic configuration. But in case of electron gain enthalpy is inversely proportional to the stable electronic configuration. Why? See, it also increases in the period. The order should be this: atomic number 6, atomic number 7, atomic number 8. It should be like this. But this having stable electronic configuration, this nitrogen is having stable electronic configuration. So why it will accept an electron, and if it will not accept an electron, so it will be very difficult for us to provide an electron from its valence shell from outside. Getting my point? So for this, the energy will not be released, but we'll have to provide energy from our side, right? And electron gain enthalpy is the value energy released, not energy provided. So here the case is opposite, so that's why NCO, it will be the order. So this was about ionization potential and electron gain enthalpy. One more thing, what is the difference in electronegativity and electron gain enthalpy? If I talk about electronegativity, so it will attract the electron towards itself. Fluorine will attract the electron towards itself. So it will have partial negative, it will have partial positive. It is about electronegativity. In case of electronegativity, atom do not get complete positive or complete negative. They will have partial positive or partial negative charge, right? While in case of electron gain enthalpy, electron will gain atom in its valence shell completely. So in case of electron gain enthalpy, there will be a complete negative or complete negative charge in case of electron gain enthalpy, but partial positive or negative charge in case of electronegativity. But in both the cases, yes, the atom will attract electron here, but in the case the electron will be completely transferred to the valence shell, right? So I hope you understood all the topics related to this chapter. So if you are having any doubt related to this chapter or related to this lecture, so you can ask in the comment section. I will be there to reply. Okay, thank you very much.